This is a video for chapter 11, part 2 on stem and leaf diagrams. Now, a stem and leaf diagram is used to organize a large amount of data. And stem and leaf diagram is a graph that shows the shape of data according to the data values. In a stem and leaf diagram, as such, the more significant digits of each value is extracted to form a stem. And the next significant digit of the value is displayed as a leaf. So in this example, number 1, the diagram shows the ages of 20 employees in a bank. So this diagram has a title on the age of the employees. So the stem over here contains these digits 2, 3, 4, 5, and 6. And these values over here, they're actually the 10th digits of the age. They are the more significant values. So you can look at the bottom where you have the key to indicate the place values of the stem and the leaf diagram. So for example, if we have 6 with a vertical line with 0, it implies there is a person who is 60 years old. And then we have another person who is 61 years old, another person 63 years old, so on and so forth. So the key in this example shows 5 with a line 3 means 53 years old. Now this is just a key, but there isn't anybody with age 53 in this particular diagram. So now back to the stem. The stems, they are arranged vertically in ascending order. So in intermediate stem values with no data values are also included. For example, this 5 over here. We do not have anybody who is of age 50 until age 59, but we still have to include the digit 5 over here. And now the next significant digit will be placed under the leaves. So in this case, the leaves, they contain the ones digits of the age. Now let's look at the first row. We've got 7 and 8 over here. It implies that there is somebody who is age 27 in this bank. And there is another person who is age 28 in this bank. You notice the arrangement for the leaves also. They're arranged in ascending order. Smallest values are closer to the stems. The largest digits are further away from the stem. So in general, we can interpret the following information from this particular stem and leaf diagram. The ages of the employees are between the youngest employee is age 27 and the oldest is age 63. So this can be very quickly extracted from the stem and leaf diagram. Now the next keyword over here is peak. The peak is between, in this case, we look for the stem and leaf which forms the longest line. Okay, so the peak age is between 31 years old and 39 years old. The next peak would be the 40 to 49 years old. Now the shape of the data, literally talking about the shape. So we focus on this shape. There are 2 points that we can make over here. So first point, the shape of the data is uneven, unevenly distributed. Okay, now for a set of data that is evenly distributed could look something like this: stem, leaf, 2, 3, 4, 5, and the number of leaves are the same. So for example, 7, 8, 6, 9, 3, 7, 0, 4. So we see that this distribution is pretty even, whereas this shape over here is quite uneven. So the second point that we can make is that the data has a thicker tail. So tail, like the tail of an animal, towards the smaller values. So where are the smaller values? Now for stem with the values for the digits from 2 to 6, the smaller values would be the 2s, the 3s, and the 4s is neither here nor there. And we can see that we have many leaves found at the smaller stem, related to the smaller stem digits. So we say that it has a very thick tail towards the smaller values. In addition, you also can say, and it has a thinner tail towards the larger values. So we see very few employees with age 50 or more. Now, part A, calculate range. There's no difference from what we have covered in the previous few videos. Range is still the maximum minus the minimum. So 63 minus 27, we get 36 years old. Now for the mode, we are looking for the most frequently appearing age. So it is not just, you should not just be looking at the peak. You have to look at the repeated leaves in line with each of the stems. So we see 27 appears once, 28 appears once. We're looking for repeated numbers. Okay, so we have repeated leaves over here, 5 and 5. So we have 2 people age 35. Next, let's move down. We see repeated 2s over here. Now this tells us that there are 3 people with age 42. And therefore, our mode is 42 years old. Just note that this didn't fall in the peak. So what is the percentage of employees in their 40s? So the percentage, we want to look for people who are belonging in this row. So there are 1, 2, 3, 4, 5, 6, 7 people. Please do not count the stem as one person. There are 7 people in their 40s. So percentage, seven out of a total 20 people times 100% will give us 35%. Now the data is represented on a pie chart, angle representing employees that are in their 40s. So angle will be 7 out of 20 times 360 degrees to give us 126 degrees. So as you can see, the skills, the concepts, they are largely the same. It is just a matter of understanding and interpreting the stem and leaf diagram correctly. Okay, so you can try example 2 by yourself. You have learned range, mode, median, mean, comparison of data. Do this by yourself. Okay, so now I will go through practice 1 with you. We have 20 students, and there was a survey done to see how many minutes they used to complete an assignment. It's shown in a stem and leaf diagram. We've got a key over here to remind us that 3 with a vertical line, stroke 2 means 32 minutes. So the teacher expected the assignment to take 30 minutes, but not everybody did. Find the percentage of students who took longer than expected. So the people who took longer than expected, they're found over here. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 of them took longer than expected. So percentage, 11 out of 20 students times 100%. So we get 55%. So the mode, find the repeated numbers. We've got 3 7s over here, and that appears the most frequently. So the mode is 27 minutes. And then we also see 3 2s appearing over here. So we have another mode of 32 minutes. The median time, so find the middle position. 20 students altogether, plus 1 over 2. We are looking at position number 10.5. Okay, start counting. From the smallest value, we want to find position number 10. Position number 1, 2, 3, 4, 5, 6, 7, 8, 9. This is position number 10. This is position number 11. However, take note, the value at position 10 is not 1. The value is 31 minutes. The value at position number 11 is not 2. It is 32 minutes. So the median will be 31 plus 32 over 2 to give us 31.5 minutes. So please take note of this. Now explain why the mean may not be an appropriate average to use to summarize the times taken by these students. Every time we talk about appropriateness of measures of central tendency, always look out for outliers, because whenever there are outliers, they will affect the mean. Either they'll pull the mean up or they'll pull the mean down. And whenever that happens, the more appropriate measure to use is actually the median. So now we can see from the distribution, there is one outlier. Okay, just one person who took really long time, 69 minutes. So start off with the facts. 69 minutes is an outlier. It increases the mean. Therefore, mean is not an appropriate average. We should be using the median in this case. So the range of times taken by a second group of students to complete the same assignment was actually 25 minutes. The range is 25 minutes. Use the information to comment on one difference. We have a few different methods, a few different approaches to comment on distributions. We can talk about the mean, we can talk about the median, talk about the range, so on and so forth. But in this case, they only provided us with the range for this second group of students. So you have no choice. You have to compare this with the range of the first group of students. So find the range for this particular group of students. We have 69 minus 24. Range, group 1, 69 minutes minus 24 minutes. We get 45 minutes. So group 1 has a range of 45, whereas group 2 has a range of 25 minutes. Range, group 2 of 25 minutes is less than the range of group 1, which is 45 minutes. So our conclusion is that time taken by group 2 is more consistent than time taken by group 1. Okay, now in practice 2, we get to try filling in the blanks for our STEM and leaf diagram. So here in the table, we have the heights of students in class A, and it's represented in a STEM and leaf diagram. So to complete it, first write down the title. In this case, it could be the height of students in class A, and the units in cm. So let's start off with the STEM 1, 2. we don't call it 12. Let's just call it 1, 2, and then we have a 3 over here. So 1, 2, 3. Let's cancel that off. Okay, 1, 2, 3. Then we have 1, 2, 8. Search for the 1, 2, 8. Okay, 1, 3, 0, 1, 3, 1, 1, 3, 7. Then move on to 1, 5, 2, 1, 6, 4. So now we have some other heights that were not found in the stem and leaf diagram, and we have to fill them in. So out of all these, the smallest value is our 140 cm, and there are 3 of them. So this being our stem, 1, 4, the final digit is 0. Next, we have another 140, another 140. Now we have 146. So put a 6 here. And next we have our 150. So make the amendment over here in your notes. The 2 should not be written here. Put a 0. The 2 should appear on the right hand side of the 0, because the leaves have to be arranged in such a manner that the smallest digits are nearest to the stem. So now we have one last portion, that is the key. The key is going to be, we can have many different answers. So for example, you can state 1, 3 with a stroke, 7. From here means or equals to 137 cm. Okay, so now write down the mode, the median, all these, you can do them. Hardy, you also can do it by yourself. Practice 3, go ahead and try also. The concepts are all the same. Now we move on to 11.2b on constructing a stem and leaf diagram, which we actually had some a taste of it just now. We completed a partial stem and leaf diagram. So in this case, when we are asked to construct the stem and leaf diagram for this set of values, the titles, this is the mass of a bag of potatoes, but it is in grams. So you can actually just copy that as of a bag of potatoes in grams. So we can choose to put the stem as having 2 digits. Okay, because we notice all the first digits, they're all 7s. So it doesn't make sense to just have the stem as 7. We need them to be different. So let's find the smallest stem consisting of 2 digits. First 79, 77, 76, 75. So far 75 is the smallest. Okay, so we should start with 75 and carry on down the line, 76, 77, 78, and 79. Now let's fill in the leaves. So 75.0, no other 75s. So go on to the next larger number, 76.5. Notice that we are not including any decimal points in our stem and leaf diagram. We're just putting down the digits. So next we move on to 77.0. 77.3. 77.4. 77.8. 77.9. And then we move on to our 78s. 78.2. 78.7. Finally, our 79.1. During the key, for example, you could write 75 with a stroke 0 means 75 0.0. This is where you put in the decimal. And 75.0 grams. Okay, now 11.2c, we have a stem and leaf diagram with split stems. Okay, so consider this set of data in example 4. We have the lengths of twigs in a garden, and we see that the stems will be 0, 1, 2, 3. We see that, wow, there are so many leaves over here. It becomes quite difficult to read. When a stem and leaf diagram has very few stems, in this case there are only 4, but fairly long leaves on some of the stems can be difficult to read. So in this case, we can break each stem into 2 halves. So one stem for the leaves from 0 to 4. So there are 5 over here, and then from 5 to 9, another 5. So the resulting diagram is a stem and leaf diagram with split stems. So you see 0, 0, 1, 1, 2, 2, and 3, 3. So in each of these stems, we'll have a maximum of 5 different digits. So let's break them down first. For the stem 0, in the first half, from 0 to 4, so we have 2, 2, 3. So put that into a diagram. 2, 2, 3. Then we have our 5, 6, 6, 8. 5, 6, 6, 8. So you get the idea. What about the 1? The stem with digit 1. Again, from the leaves from 0 all the way to 4. So these are the ones. 0, 0, 0, 2. Next, we have 6, 6, 8, 8, 9. And notice that when you draw the leaves, put them neatly in proper columns, because we will need to, the shape of the distribution is important for our description of the diagram. So you carry on with this. For the 2s, we have 0, 0, 1, 2, 3, 3. Followed by 5, 5, 6, 7, 7, 8, 8, 9, 9. For the 3s, 0, 1, 1, 1, 2, 2, 3, 3, 3, and 4, 4, 4, and a 5 and 6. So this is our stem and leaf diagram with split stems. Then the interpretation is still the same. The descriptions will also be the same. Now, the next type of stem and leaf diagram is called a back-to-back stem and leaf diagram. Kind of similar to our previous notes in our dot diagrams, where we have a back-to-back dot diagram, one on top, one at the bottom. But for stem and leaf diagram, we have stem in the middle, leaves on the left, leaves on the right. I want to draw your attention to the leaves on the left-hand side, because we are already familiar with the leaves on the right-hand side. For the leaves on the right-hand side, we put the smallest digits closest to the stem. So we end up having this in ascending order. So you observe for the leaves on the left-hand side, it is consistent in that we are still placing the smallest digits closest to the stem. So this is consistent. Smallest digits closest to stem, whether it is left-hand side or right-hand side. So find the mode for factory A. Factory A, we're just interested in this. Looking for the most frequently occurring number. So we've got repeated ones over here. The mode is starting from the stem to 1, 21 light bulbs. Find the median for factory B. So middle position. We have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 plus 1 over 2. So the middle position is 6.5. Looking for position number 6 and position number 7. This is 1, 2, 3, 4, 5, 6, and 7. Median for B will be 38 plus 40 divided by 2. So we get 39 light bulbs. So which factory's production of light bulbs is better? This is a question on performance. So whenever we talk about comparison, usually it falls under two categories: performance as well as consistency. Consistency we will look at the range when we want to comment about consistency. Anything else that is not related to consistency will be grouped under performance. So in this case, which factory's production of light bulbs is better? Then think about it. Do you want to find the factory with a higher number, with a larger value of the light bulbs in this stem and leaf diagram, or do you want to find the factories with the smaller values? So we go back to the question again. We are actually looking at the number of defective light bulbs found in 12 boxes of 100 light bulbs from different factories. These numbers over here represent number of defective light bulbs. So for a factory with better production, we want the number of defective light bulbs to be small. But it doesn't make sense just to compare the smallest numbers of the light bulbs in both factories. We should consider the median. Roughly on average, what is the number of defective light bulbs that each factory produces? So in this case, we should consider mean, median, mode. So these are three options that you can consider, but it becomes an art to choose one of them that is appropriate. So one of the strategies that we can use if you cannot make up your mind is to look at part A, the previous part. They've already told you to find median for factory B. So you ask yourself, is median an appropriate measure for the central tendency? And in fact, the median is suitable in this case. So we already have the median for B. Let's find the median for A. So the same 12 boxes, looking at position number 6 and position number 7, starting from the smallest, start counting. 1, 2, 3, 4, 5. This is number 6 and number 7. So we're going to be taking the average of 21 and 23. Not 3 and 1, 21 and 23. So divide this by 2, we get 22 light bulbs. So now we compare the median for A and for B. Median A, which is A, 22 bulbs. This is smaller than the median for the B, and state the value 39 bulbs. Since this is smaller, we conclude that factory A is better, as it has generally fewer defective bulbs. So practice number 4, you can do it by yourself as well. Practice, the next question over here, also do it by yourself as your homework. All the question types in these few homework questions are the same. So here you also have your homework question. Please complete it and your teacher will go through it with you.